Welcome to Spring LIB.
Okay, we've got double bond with bromine, chlorine, and chlorine. Is this E or Z? Okay, well, we've got to assign priority to the things on either side of the double bond. Bromine is a higher priority than chlorine because bromine has a higher atomic mass or atomic number. And then chlorine has a higher priority than this hydrogen for the same reason. So are these on the same side or opposite side? They're on opposite sides. So that's E. The first one is E. Let's continue. So now we've got this sort of branch structure. Okay, so on the right-hand side, it goes carbon, carbon, hydrogen, 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 hydrogen. They're the same so far. And the first difference is the bromine versus the iodine. And iodine has a higher priority than bromine. So that's our priority rules here. Well, whereas on the other side, we've got 3 hydrogens here. But here we've got 2 hydrogens and a deuterium. And deuterium is hydrogen with an extra neutron. So when we are comparing isotopes, we select the isotope with the higher mass. So in this case, this is side 1, and this is side 2, or this side has higher priority than the other, I should say. So now our highest priority substituents are on opposite sides again. So that's, not Z, E for Engeigen, or German for opposite. Okay, let's continue. Now we've got NO2 branching off of the carbon, fluorine, carbon, and then a hydrogen. So NO2 versus fluorine, which has the higher atomic number? It's the fluorine, right? Because recall, this isn't NO2 actually is, if we were to draw it all the way out, would be a bond to a nitrogen, and that nitrogen is bound to an oxygen, right? So we're actually comparing fluorine directly to nitrogen. We can ignore the oxygens. Okay, so fluorine's higher priority. And here we've got carbon versus hydrogen. And in this case, they're on the same side, so we get Z for zusammen, German for same. Finally, NO2, fluorine, that's the same comparison we had before. Fluorine, and then a carbon with an iodine sticking off. So NO2 versus fluorine, we already know that fluorine is higher priority. And then here, what we're comparing is fluorine to, remember, there's a carbon here that has 2 hydrogens. So we're comparing fluorine to carbon. In this case, fluorine wins because fluorine has a higher atomic number. So they are on opposite sides, and we get E.